Welcome to SAT School. I am your instructor from satschool.com. This is our second video on HCF and LCM. Now let's get started. This is where we left on last video. If you have not watched that video, I strongly recommend to watch that first. Click the I button above and watch the video. Now let's complete. And I hope you manage this. If not, let's have a look. Here the first expression, which is x cube minus y cube, is in the form of a cube minus b cube, that is equals to a minus b, a square plus ab plus b square. So you can write x cube minus y cube in the form of x minus y, x square plus xy plus y square. So these are two factors from the first expression. Now we have the second expression, which is x square plus xy plus y square, and we write is as it is. That is the second expression. Now if you look at the first expression and second expression, there is one common factor between them, which is x square plus xy plus y square, and that common factor is HCF. That is the highest common factor between two expressions. Now the remaining factor between first and second expression, which is not common, is x minus y. So x square plus xy plus y square, that is a common factor, and x minus y is not common. Now LCM for these two terms, these two expressions, is x minus y, x square plus xy plus y square, and that can be written in the form of x cube minus y cube, and that is the LCM. Now here is practice question number 6. We have two expressions, a4 minus a square plus a plus 1. The first expression, a4 minus a, so there is a common between two terms, a4 and a. So it can be written as a cube minus 1, because a is common between those two terms. A cube minus 1, that is in the form of a cube minus b cube. Here you can write 1 as 1 cube or simply 1. So a cube minus b cube is in the form of a minus 1, a square plus a plus 1. Again, a cube minus 1 is in the form of a cube minus b cube. Now the second expression is written as it is, a square plus a plus 1. Here a square plus a plus 1 is common factor between first and second expression, and that common factor becomes the highest common factor, that is HCF. Now remaining factors are a and a minus 1, and including those factors we have LCM, that is a minus 1, a square plus a minus 1, and this can be even write as a cube minus 1. Now practice question 7. Here we have two expressions, 3x cube minus 27x and x cube plus 27. The second expression, which is x cube plus 27, is in the form of a cube plus b cube, or we can write in the form of a cube plus b cube. 27 is cube of 3. So x cube plus 27 can be written in the form of a cube plus b cube, which is equals to a plus b, a square minus ab plus b square. Here the first expression is 3x cube minus 27x. Now we have common between first and second terms. The first and second term, they have common 3x. So if 3x is common, then there will be x square minus 9, and x square minus 9 can be written in the form of a square minus b square, which is a plus b, a minus b. In this case, x plus 3 and x minus 3. The second expression is x cubed plus 27, which is in the form of a cube minus, a cube plus b cube. That is x cube plus cube of 3. That will be equals to x plus 3, x square minus 3x plus 9. As you can see above, a cube plus b cube is in the form of a plus b, a squared minus ab plus b square. Now looking for common factor, we have one factor in common between first and second expression, and that is x plus 3. And that is the highest common factor between first and second expression. That's why HCF is x plus 3. Again, find HCF between x4 plus 4 and 2x squared plus 2x plus 2x squared plus 4x plus 4. The first expression, x4 plus 4, it can be written in the form of a square plus b square, which is equals to a plus b whole square minus twice ab. The first expression, x4 plus 4, you can write as x square whole square plus 2 square. Here a means now x square, b means 2. So writing the formula for a square plus b square, we get a plus b whole square minus 2ab. Again here a means x square and b means 2. Now the second term 2x square plus 2, 2x square times 2 can be written as 2x whole square. Now this is in the form of a square minus b square, and the formula is a plus b, a minus b. Now you can arrange the terms, then x square plus 2x plus 2, x square minus 2x plus 2. So these are two factors from the first expression. We have the second expression, which is 2x square plus 4x plus 4. Now if you look at each term, you can take 2 common from each of them. If 2 is common, then x square plus 2x plus 2. So we have x squared plus 2x plus 2 as common between first and second expression, and that is the highest common factor between those two expressions. Now this is practice question number 9, which is to factorize. Even this is not HCF and LCM, but these kinds of expression comes in HCF and LCM. Now let's factorize this. You should know how to factorize this because you should be very familiar with these kinds of factorization. We don't use formula here to get factors of this expression. Rather, we factorize to get factors. Now, in this kinds of expression to factorize, the first step is to identify the multiple of constant and coefficient of a square. Here the coefficient of a square is 1 and the constant is 35. So if you multiply 1 and 35, that is equals to 35. Here the given is a square minus 12a plus 35. Again, to factorize, the first step is to get the product of constant and coefficient of a square. In this case, coefficient of a square is 1 and constant is 35. If you multiply, then you get 35. Now the second step is to divide the middle term here, minus 12a, into two terms. Here we have 12a. We have to divide or split this 12a into two terms. Now how we divide? How we split this? Now with the help of 35. So here factors of 35 are 5 and 7. 5 times 7 is 35. Now you can get minus 12a using factors of 35. If you write minus in front of both, like minus 5 and minus 7, then you'll get minus 12. So this can be written as a square minus 7a minus 5a plus 35. So this is how we divide the middle term into two terms, or we split that into two terms. Now, if you look at the first two terms, a is common. Here now we get a minus 7. If you look at last two terms, minus 5 is common. So if you take minus 5 as common, then the plus inside will change into minus. That is a plus in front of 35 change into minus. So minus 5 is common. Now a minus 7. So that will be equals to a minus 7, a minus 5. So this is how we factorize the given expression. And I know you are very well familiar with this type of factorization. Now let's move to practice question number 10. Now here we have to find HCF and LCM of three expressions: x plus 1 whole square, x square minus 1, and x square plus 4x plus 3. The first expression, x plus 1 whole square, can be written as x plus 1, x plus 1. The second expression, x square minus 1, is in the form of a square minus b square, which can be written as a plus b, a minus b. The last expression, x square plus 4x plus 3. So this is what we have to factorize that we did in practice question number 9. So I want you to practice this. I want you to try this and give a try. We have three expressions, first, second, and third. And the third expression is to factorize like in practice question number 9. I think you can try. You can manage this. So this is for today. I'll meet you in next video. If you like the video, please don't forget to subscribe. Take care.